When dealing with multiple power sources in a building, specific requirements apply to disconnects and grounding, as outlined in the National Electrical Code. Let's explore these requirements referencing relevant NEC code sections to ensure clarity and compliance. Firstly, regarding grouping disconnects, the NEC mandates that disconnecting means for individual units of equipment, feeders, or branch circuits must be grouped in a common enclosure or placed in close proximity to the equipment they serve. This is stated in section 408.2. Where a common enclosure is used, the circuits supplying individual loads within the enclosure must be clearly identified. In the scenario where a feeder from one building supplies another, this feeder becomes a source of supply for the receiving building. Consequently, the disconnects for both the feeder and the original service in the building must be grouped together. Exceptions to this rule may exist, but generally grouping is required to ensure that all power sources can be easily and safely disconnected at a single location. Secondly, considering the labeling of disconnects, the NEC requires that disconnects be labeled to indicate the presence of more than one power source to the building. This ensures that individuals working on the electrical system are aware of all potential sources of power and can take appropriate safety precautions. Specifically, section 408.2. B states that where there are multiple sources of power for a building or structure, the disconnect must be so arranged that all sources of power, including the service and the feeder or feeders, must be simultaneously disconnected from all conductors of the system. Furthermore, section 408.2. C mandates that where there are multiple sources of power, each disconnect must be marked to indicate the source or sources of power. This labeling should be clear, concise, and easily visible to anyone accessing the disconnects. Adequate labeling is crucial for safety and helps prevent accidental energization of circuits during maintenance or repair work. Thirdly, concerning feeder grounding, the NEC requires that the feeder ground must tie to the ground at the building it serves. This ensures that a proper grounding electrode system is established at each building and interconnected to the grounding electrode system of the building from which the feeder originates. This requirement is outlined in section 250.32. B, which states that where an alternating current feeder supplies equipment at more than one building, a grounding electrode system must be provided at each building and interconnected to the grounding electrode system of the building from which the feeder originates. This interconnection is typically achieved using a grounding electrode conductor. The purpose of this requirement is to provide a low impedance path for fault current to return to the source, which helps to ensure the proper operation of current protection devices and minimize the risk of electrical shock. By establishing a grounding electrode system at each building and interconnecting them, a more robust and effective grounding system is created, enhancing electrical safety and system performance. In summary, when a building has multiple power sources, such as a service and a feeder, several key requirements must be met. Firstly, disconnects for all power sources must be grouped together unless specific exceptions apply. Secondly, all disconnects must be clearly labeled to indicate the presence of multiple power sources and identify the source or sources of power for each disconnect. Thirdly, a feeder ground must be connected to the grounding electrode system at the building it serves, and this system must be interconnected with the grounding electrode system of the building from which the feeder originates. These requirements are essential for ensuring electrical safety, preventing accidental energization of circuits, and providing a reliable path for fault current to return to the source. Always refer to the latest edition of the National Electrical Code and consult with qualified electrical professionals to ensure compliance with all applicable regulations and best practices. Let's elaborate further on the grouping of disconnects as per NEC section 408.2. This section is crucial in scenarios involving multiple power sources, such as when a building receives power from both a utility service and a separate feeder from another building. The primary intent behind this requirement is to ensure that all sources of power to a building can be quickly and easily disconnected in a single location, enhancing safety during maintenance, repairs, or emergencies. The code specifies that disconnecting means for individual units of equipment, feeders, or branch circuits must be grouped in a common enclosure or placed in close proximity to the equipment they serve. This means that if a building has a service disconnect and a feeder disconnect, both disconnects should ideally be located together in a single enclosure or, at the very least, in close proximity to each other. This arrangement allows personnel to energize all power sources to the building with minimal effort, reducing the risk of electric shock or other hazards. When a common enclosure is used to house multiple disconnects, the code also mandates that the circuits supplying individual loads within the enclosure must be clearly identified. This means that each disconnect must be labeled to indicate which circuit or load it controls. This labeling is essential for preventing confusion and ensuring that the correct circuits are de-energized when necessary. Clear and accurate labeling also facilitates troubleshooting and maintenance activities. It is important to note that there may be exceptions to the grouping requirement in certain situations. For example, the code may allow for disconnects to be located in different locations if it is impractical or infeasible to group them together. However, in such cases, additional precautions may be required, such as providing remote-controlled devices or additional labeling to clearly indicate the location of all disconnects. It is always advisable to consult with a qualified electrical professional to determine the most appropriate and compliant arrangement for disconnects in a given situation. Moving on to the labeling of disconnects, as outlined in NEC sections 408.2 B and 408.2 C. Proper labeling is paramount when a building has multiple power sources. These sections emphasize the importance of clearly indicating the presence of all power sources and providing information on how to disconnect them safely. Section 408.2 B states that where there are multiple sources of power for a building or structure, the disconnect must be so arranged that all sources of power, including the service and the feeder or feeders, must be simultaneously disconnected from all conductors of the system. This means that the disconnects must be designed and installed in such a way that all power sources can be de-energized at the same time, typically through the use of a main disconnect or a series of interconnected disconnects. This requirement is crucial for ensuring that personnel can safely work on the electrical system without the risk of being exposed to live conductors. Section 408.2 C further specifies that where there are multiple sources of power, each disconnect must be marked to indicate the source or sources of power. This means that each disconnect must be labeled with information that clearly identifies the power source it controls. For example, a disconnect for utility service should be labeled as service disconnect, while a disconnect for a feeder from another building should be labeled as feeder disconnect from building B. The labeling should be durable, legible, and easily visible to anyone accessing the disconnects. In addition to identifying the source of power, the labeling may also include other relevant information such as the voltage, amperage, and circuit number of the disconnect. This information can be helpful for troubleshooting and maintenance purposes. It is important to note that the labeling requirements may vary depending on the specific application and local regulations. Always consult with a qualified electrical professional and refer to the latest edition of the National Electrical Code to ensure compliance with all applicable requirements. Finally, let's delve deeper into the feeder grounding requirements outlined in NEC section 250.32. B3. This section addresses the grounding of alternating current feeders that supply equipment at more than one building. The primary objective of this requirement is to ensure that a proper grounding electrode system is established at each building and interconnected to the grounding electrode system of the building from which the feeder originates. This interconnection is essential for providing a low impedance path for fault current to return to the source, which helps to ensure the proper operation of overcurrent protection devices and minimize the risk of electrical shock. Section 250.32 B3 B states that where an alternating current feeder supplies equipment at more than one building, a grounding electrode system must be provided at each building and interconnected to the grounding electrode system of the building from which the feeder originates. This means that each building must have its own grounding electrode system, which typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The grounding electrodes must be installed in accordance with the requirements of NEC sections 250.52 and 250.53. The grounding electrode system at each building must be interconnected to the grounding electrode system of the building from which the feeder originates. This interconnection is typically achieved using a grounding electrode conductor, which is a conductor that connects the grounding electrode system at one building to the grounding electrode system at the other building. The grounding electrode conductor must be sized in accordance with the requirements of NEC section 250.66. The interconnection of the grounding electrode systems helps to create a more robust and effective grounding system, which enhances electrical safety and system performance. By providing a low impedance path for fault current to return to the source, the grounding system helps to ensure that overcurrent protection devices, such as circuit breakers and fuses, will operate quickly and effectively to clear faults and prevent electrical hazards. It is important to know that the grounding requirements may vary depending on the specific application and local regulations. Always consult with a qualified electrical professional and refer to the latest edition of the National Electrical Code to ensure compliance with all applicable requirements. In addition to the requirements discussed above, there are several other considerations to keep in mind when dealing with multiple power sources in buildings. These include, firstly, coordination of overcurrent protection devices. When a building has multiple power sources, it is essential to coordinate the overcurrent protection devices to ensure that faults are cleared quickly and effectively without causing unnecessary power outages. This coordination typically involves selecting overcurrent protection devices with appropriate time current characteristics to ensure that the device closest to the fault will trip first, while upstream devices will remain closed to maintain power to other parts of the system. Secondly, surge protection. Buildings with multiple power sources may be more susceptible to voltage surges and transient overvoltages. Therefore, it is important to provide adequate surge protection to protect sensitive electronic equipment from damage. Surge protection devices should be installed at the service entrance and at other critical locations throughout the building. Thirdly, emergency power systems. In some cases, it may be necessary to provide an emergency power system to supply power to critical loads during a power outage. Emergency power systems typically consist of a generator, automatic transfer switch, and battery backup system. The emergency power system should be designed and installed in accordance with the requirements of NEC Article 700. Fourthly, compliance with local regulations. In addition to the requirements of the National Electrical Code, it is important to comply with all applicable local regulations and building codes. These regulations may vary depending on the location and may include additional requirements for disconnects, grounding, and other electrical equipment. Finally, documentation and labeling. It is essential to maintain accurate documentation of all electrical systems and equipment, including disconnects, grounding systems, and emergency power systems. All equipment should be clearly labeled to facilitate maintenance, troubleshooting, and future modifications. By following these guidelines and working with qualified electrical professionals, it is possible to safely and effectively manage multiple power sources in buildings and ensure the safety of occupants and equipment. Let us delve further into specific scenarios and practical applications related to multiple power sources in buildings. Consider a commercial building with a primary utility service and a backup generator. In this case, the NEC requirements for grouping disconnects, labeling disconnects, and feeder grounding would apply. The service disconnect for the utility power and the generator disconnect would need to be grouped together or located in close proximity to each other, allowing for easy and simultaneous disconnection of all power sources. Each disconnect would need to be clearly labeled to indicate its source of power, such as utility service disconnect and generator disconnect. The grounding electrode system for the generator would need to be connected to the building's grounding electrode system, ensuring a common ground reference for all power sources. Another example involves a multi-tenant building where each tenant has their own electrical service. In this situation, each tenant's service disconnect would need to be located within their individual tenant space or in a common area accessible to the tenant. Each disconnect would need to be labeled with the tenant's name or unit number to identify the corresponding service. The grounding electrode system for each service would need to be installed in accordance with NEC requirements, ensuring proper grounding for each tenant's electrical system. In industrial settings, it is common to have multiple power sources to ensure reliability and redundancy. For instance, a manufacturing plant may have a primary utility service, a backup generator, and an uninterruptible power supply, abbreviated UPS, system to protect critical equipment from power outages. In this case, the disconnects for all power sources would need to be grouped together or located in close proximity, and each disconnect would need to be clearly labeled to indicate its source. The grounding electrode systems for all power sources would need to be interconnected to provide a common ground reference. Furthermore, the overcurrent protection devices would need to be carefully coordinated to ensure that faults are cleared quickly and effectively without disrupting power to other critical equipment. In healthcare facilities, the requirements for multiple power sources are particularly stringent due to the critical nature of patient care. Hospitals and other healthcare facilities typically have multiple power sources, including a primary utility service, an emergency generator, and an uninterruptible power supply, abbreviated UPS system. The disconnects for all power sources must be grouped together and clearly labeled, and the grounding electrode systems must be interconnected. In addition, healthcare facilities must comply with specific requirements for essential electrical systems, which are designed to provide power to critical equipment during a power outage. These systems must be tested and maintained regularly to ensure their reliability. When designing and installing electrical systems with multiple power sources, it is crucial to consider the specific needs and requirements of the application. A thorough understanding of the NEC requirements and local regulations is essential for ensuring safety and compliance. Consulting with qualified electrical professionals such as electrical engineers and licensed electricians is highly recommended to ensure that the electrical system is designed and installed correctly. Additionally, regular inspections and maintenance are necessary to ensure the continued safety and reliability of the electrical system. In summary, the presence of multiple power sources in buildings necessitates careful attention to the requirements for grouping disconnects, labeling disconnects, and feeder grounding, as outlined in the National Electrical Code. These requirements are essential for ensuring electrical safety, preventing accidental energization of circuits, and providing a reliable path for fault current to return to the source. By adhering to these requirements and working with qualified professionals, it is possible to safely and effectively manage multiple power sources in buildings and protect occupants and equipment from electrical hazards.